Okay, question 3. So find the charge, Q, flowing through a device if the current is this. And then we have time-dependent functions of current, which is I. So notice the units. This is amps, milliamps, microamps, and back to regular amps. Then they've given us values of the amount of charge. Looks like they're all at time 0, so they're all initial values. They just need to give you a value, otherwise you're not going to be able to get there. Because I is just how much charge is flowing and how fast it's flowing. Q is the amount of charge that has flowed. So there we have coulombs, no units there because it's 0. It doesn't technically need units. And then microcoulombs. So they match up, amps with coulombs, milli with nothing, micro with micro, and amps with nothing. So we're not going to have to worry too much about the units on this one. If you ignored them, you would still get a good answer for it. Okay, so I'm going to go ahead and start on it. You should have a go at it yourself. Let me get rid of this. Make sure I have the question up over here. Yep, okay. So in order to do this, we're going to have to make, I'm going to use a capital I for current instead of the lowercase I. I just like it better. So current is the change in charge with respect to time. And we want the charge though, so if we just move dt over to the other side and rearrange it, we can get dq is equal to I times dt, and then you sum up all charges, sum up all of that side, which means integrate, and you end up with basically q as some function of time. Well, so there's different ways to do it. So you can get this equals that from some 0 time to some time t. And so that's how we're going to do it here, because they went ahead and gave us initial values for that. If they didn't give us initial values for that, well, then we do it some other way. But they did, and so this is how we shall do it. So for this one, I is equal to 3 amps, and we're told that Q, 0, put a comma there, is equal to 1 coulomb. So we'll just, basically we'll have to solve for that, and we will get that the integral, so I'll have Q at t is equal to the integral from 0 to t of 3. I'm going to forget the units, they'll just kind of get in our way, dt. Let's do that later. Let's just do the integral first. And that's going to be 3t. Then applying our little formula there, we will have q at t is equal to 3t plus value of q at 0, which was 1. And that is coulombs. So the amps was in, sorry, the current was in amps, and the charge was in coulombs, and so that's all squared away. So there's that. Let's see, yeah, we'll do B over here. So I, the current, is equal to 2t plus 5, and that is milliamps. And then the charge at 0 is big fat 0. Right on. Okay, so same deal. We're going to do the integral from 0 to t, just some arbitrary point in time, times, of 2t plus 5 dt is equal to, let's see, become a t squared, and you'll divide by it, so it's just t squared plus 5t. Yep. And then we will have, and then it's plus 0. So yeah, so then when you do q at t will be this thing, t squared plus 5t plus nothing plus this thing, which is just 0, so we don't even need a plus. It was milliamps there, the charge was 0, and so it's millicoulombs. All right, I'm going to erase this, and then we will do number C, because it looks a bit bigger. Okay, so now let's do part C. So here, I is equal to, make that look more like an I, 20 cosine 10t plus pi by 6, and that's in good old microamps. And then our initial amount of charge is 2 microcoulombs. Okay, so same thing. So let's just find out what this integral is. So integral from 0 to t of 20 cosine 10t plus pi by 6 dt. All right, so the 20 can come out. And then you just have the cosine thing. We'll write it back out. 0 to t dt. All right, so let's see, if you have sine, the derivative of sine is plus cosine. So then the integral of sine, cosine must be sine, all right? I just forget which one gets the sign change. Haha, the sign change. All right, so the 20 is outside of there. The integral is happening inside the square brackets. This is going to change into a sine of 10t. Everything inside should stay the same. We're not going to have anything regarding negative sign. But if we did the derivative of this, we would multiply by a 10. That 10 isn't there, and so we need to preemptively get rid of that 10 by dividing by it. Pi over 6 would go away in a derivative. That'd be 10. Cancel out the 10, the 20's there. So, yeah, looks good. All right, so then the limits on this is from 0 to t. So we'll have the 10 can come out, and that will be a 2 times, so the sine at the t would just be this thing. So sine of 10t plus pi over 6 minus sine of pi over 6 when you put in the 0. Okay, so 2 sine 10t plus pi over 6. I don't know what sine of pi over 6 is. So we're going to use this. So make sure we are in radian mode. Can you see that? Yeah, it's very blurry. Okay, so sine of pi over 6 is, 1/2. Wait. Oh yeah, that's one of those ones that you're supposed to memorize, right? Yeah, well, that's what happens. All right, so 1/2. 1/2. We'll just pretend like I had that memorized, right? Okay. Yeah, let's distribute this 2 before we move on. Let's go 2 sine. I'm just going to write that, and we'll all know what that means. -1. All right, so that's the integral, and we know that the charge at t is equal to that integral plus the initial charge. So this is going to be, because this here, right, represents the total amount of charge that has passed by some particular point between the times 0 and whatever time we're currently at, t. And to know the total amount of charge that has ever passed by that point, you need to know how much has passed by that point between these 2 times, plus any amount that passed by there before that. So that's why you have to add that on. Okay, so what are we doing? Right, so 2 sine 10t plus pi over 6 minus 1 for here, but plus 2 for there. So it'll be minus 1 plus 2, and that's going to give us a plus 1. And the units on that will be microcoulombs there, microamps there, so we're good with microcoulombs. All right, now we'll do D. Let me pause this and I'll erase. I'm back. All right, so D. Part D. I is equal to 10, oh boy, minus 3t, 30t. I'll shortchange do a whole bunch of t's. Sorry about that. Minus 30t sine of 40t. Okay. And then I guess they felt like they gave you enough to do, so they made the initial charge 0. So there's probably like some kind of real fancy way to do this, right? Especially if you just kind of know a formula. I don't. So I guess we do integration by parts then. Integration by parts twice, because the sine is just going to turn into a cosine. And then you'd have to do it again. You're going to get those two terms, those two factors in there. And then an integral of the exponent with the sine. No, it would be a cosine at that point. Yeah, it would be a cosine at that point. So then you have to do it again. And I could take a guess, but I would just end up probably guessing wrong in some way. So we'll just go for it. So we'll ignore the 10, and we'll just kind of break this down into exactly what it is, including I'm going to drop the 30 and the 40 as well. And we're going to say that we have some f at x equal to e to the ax sine of bx, just to make it easy. So the minus 30 would be a and the b would be 40. This is just so that way there's as little as possible that we have to write out for this. Okay, so when we want the integral of this, so integral of e to the ax sine bx dx. Say u is equal to eax, therefore du would be aeax. dv, we can make that be sine of bx dx. Therefore, the integral of that giving us v would be equal to 1 over b. And I just did this on part C, right? So the integral of that would really be minus cosine bx, right? Let's double check that. So sine's derivative is positive cosine, so its integral must be negative cosine, right? I'm not sure that's correct. So cosine starts at 0 and then goes negative. So the derivative of cosine is negative sine. And so we have the derivative going this way and the signs change, so that works out. Okay, so then this becomes uv minus integral v du, put them in, minus 1 over b eax cos bx, integral v plus 1 over b a for this, eax cos bx. There should be a dx there. Dx. How do I want to do this? Because I guess we could just repeat the process then. Yeah, and then we'll just repeat it. Yeah, okay. Ugh, what a pain in the butt. Why do they do this to me, huh? Why do they gotta do this to me? I'm gonna have the same issue I did over here, right? Yeah, but maybe we can just make use of what we already know from here. All right, you think I should probably write out sine and cosine derivatives and just have them on me. Anyway, so doing this integral now. So integral eax, I'm going to write it over here so that way we can definitely keep track when we get to a point of having it all done, subbing it all back in. We know exactly what to do. So u will be eax, du is aeax dx, dv is cosine bx dx, v will be 1 over b sine bx, and that's the integral. So the derivative of cosine gave us negative sine. So the integral of it should be giving us positive sine. Should be the opposite. Yeah. Okay. Then we'll plug it in over here. So then that integral on this side will be equal to uv, so we'll go 1 over b eax sine bx minus integral v du, so a over b eax sine bx dx. All right. So that's this. So what I'm going to do is abbreviate things here. So integral eax, I'm going to use capital C to represent cosine of bx dx is equal to 1 over b eax. S is sine of bx. Just kind of helps make everything look a little bit more clear about matching terms. So there's that. And over here we have this. So we see that we can change this guy into this one. So let's do that, where we have here integral of eax s dx, which is the integral we actually want to know, is equal to minus 1 over b eax c. Yep, just making sure I'm copying it right. Plus a over b times this thing, 1 over b eax s minus a over b integral eax s dx. Simplifying this side, 1 over b. I'm just going to write e now. I'm going to drop the exponent. They're all e to the ax, so we'll just remember that. C plus a over b squared e s minus a squared by b squared e. Don't forget the integral sign. Integral e s dx. Okay. So recognizing that this and this are the same integral, we can put those together and we get integral es dx plus a squared by b squared integral es dx. That is, of course, going to be integral es dx times 1 plus a squared by b squared. And that's going to then be equal to these two terms from the other side, minus 1 over b ec plus a over b squared es. All right. Boy, I hated that. Let's get rid of this stuff. Okay, so we have that, the integral, I'm just going to copy it down, the integral of e to the ax sine bx I'll just leave it here, times 1 plus a squared by b squared is equal to a by b squared e to the ax sine bx minus 1 over b e to the ax cosine b cliffhanger x. There we go. All right. I don't need any of this crap anymore. I'll pause. Okay. Oh. Okay. Monitor fell asleep. All right. Let's see. So, this thing. So we really just want the integral. So let's just do this. 1 plus a squared by b squared. And then we don't need that part. Floppy, but what are you going to do? Okay. All right, so what were we doing? We were trying to find out what q is, right? Right, so to find out what q is, same thing as we've been doing. You need the integral from 0 to t of I dt, and then add on to that q at 0. Okay, so q at 0 is 0, so that's nice. We know that. And then we have now this relationship here. So this integral is the integral from 0 to t of I, which is 10 e to the minus 30 t sine 40 t. It's a 40. Okay, so according to our formula then, a is equal to minus 30 and b is equal to 40. So that makes 1 plus a squared by b squared equal to something. So that's going to be minus 30 divided by 40, square that, 1 plus that, 1.5625, 1.5625, and a by b squared will be minus 30 by 40 squared, 0.01875. I'm assuming these turn into really great fractions, but I don't really feel like doing that. We'll do that at the end. 1 over b will be 0.025. We'll just fractionalize it at the end. That's the technical term. Okay, so this integral just becomes this thing, which we have these values for right now. So all we got to do is put them in. So it's going to be this one for the first thing. So that'll be minus 0.01, what is that? That's going to take up too much space. 0.01875. Let's do fraction now. 3 over 160. Let's do fractions now. So it's going to take up too much space on the board to write a big long decimal like that. Minus 3 over 160. For that, and then we have e to the minus 30 sine 40t minus, and b was 40, so 1 over 40 minus 1 over 40 e to the minus 30, this should be t cosine 40t. I'm gonna erase that. Okay. And then we have to divide by this bottom thing, 1.5625. So that's following this formula. 40, this thing, which is this guy, okay. So this is the evaluation of the antiderivative at t, and then you need to do minus the evaluation of it at 0. Also, don't forget to multiply everything by 10 when you're done. So put that there. Okay, just a little reminder note. All right, so then this one will be, so at 0, so at 0, the sine term is gone. This one is still there though, so we'll have minus this second term, which the cosine is gone, which is nice. The exponential just becomes 1. We have the minus, so it'll become plus. 1 over 40 divided by 1.5625. And then that whole thing gets multiplied by 10. So multiplying that whole thing by 10 would reduce this to minus 3 by 16 e to the minus 30t sine 40t. This term by 10 minus 1 over 4 e minus 30t cosine 40t. This term by 10 plus 1 over 4. The whole thing, get rid of my head, I'll just slide it over. The whole thing gets divided by 1.5625. So I think that's what it is. There's probably ways that you could make it nicer. Like there's a 4, factor of a fourth, factor of a fourth, factor of a fourth there. So you could take that out. have a 1/4 in there. What fraction does this become? 1.5625 turns into 25/16. Yeah, so there's going to be some additional canceling because of that. So there's definitely some simplification that you could do to it. But I don't really see the point. I mean, it's such a crappy thing just for like a part D on question 3. Jesus. Anyway, the units though, amps, units on this was nothing, so the units are coulombs.